Hello, everyone, and Happy New Year. Welcome to the Potty Center and today's event, The Big Questions in Science, a conversation with Dr. Rupert Sheldrake and conversation with Àlex Gómez-Marín. Rupert Sheldrake has created a 12-part online course with Advaya, where he argues that the sciences are being constricted by 10 assumptions that have hardened into dogmas. This mind-transforming course is based upon Rupert's award-winning best-selling book, The Science Delusion. In the US, it is called Science Set Free. It makes these ideas accessible to scientists and non-scientists alike. Today, Àlex and Rupert will discuss some of the ways in which the scientists could be liberated and revitalized. Facing an hour-long, lively and spontaneous dialogue between Àlex and Rupert, we will open the session to questions from our audience. I will now hand over the discussion to Àlex.
Thank you so much, Michael. Well, what a great way to start the year. I'm so happy to be with all of you and to be with you, Rupert, in public. Spend a lot of time having conversations in private, and it's always a joy to talk to you. In fact, we spoke today already, and here we are again. Thank you for accepting the invitation. And let's talk about this course and your book and science writ large. Would you want to give us start with an overview of the course, or let's start wherever you wish?
Well, the course is based on my book, The Science Delusion, as Michael already said, and this is the 2020 second edition of the book. So the book first came out in 2012, and the course, which is professionally recorded with Advaya, really brings it up to date. So for those who prefer reading, then read the book. But if you prefer that kind of up-to-date presentation, then the course is for people who'd like to learn about it as a course rather than just reading a book. And the reason I've made a course out of it is because it deals with the foundations of contemporary science, the 10 fundamental assumptions on which the sciences are based. Started out as simplifying assumptions, working hypotheses, but over time they've hardened into dogmas, and most people think of them as unquestionable truths. And so my method, as you know, is to turn them into questions and then see how well these dogmas turn out when looked at in the light of scientific evidence itself. And the whole point of the course really is that every one of these dogmas has become a kind of limiting straitjacket for huge areas of scientific research. And when we realize that these are actually open questions instead of closed questions, then it has a liberating effect on the sciences. The subtitle of the book in English, in the English edition, is Freeing the Spirit of Inquiry. And that's really encapsulated in the American title, Science Set Free. So the aim really is to help liberate scientific thinking, both for scientists and for non-scientists, because many people who are enslaved by these dogmas are not practicing scientists. They're people who've learned a bit of science at school, read a few popular science articles, and through the impressive successes of technology like smartphones and jet planes and antibiotics and keyhole surgery, through these impressive advances, assume that science must be right. It works so well, it's changed all our lives. But actually, many people's lives have been shaped by these dogmas without realizing they're highly questionable. So I hope it will be liberating for almost anyone, because all of us in the modern world have had our worldviews shaped by these dogmas of science.
So if you could reflect on your target audience, not just of the course or of your books, but generally, having in mind that there's a part of it which is outreach, there's a part of it which is the so-called public understanding of science, but also to scientists themselves, especially when we hear all over the place, science says. And so, as I know your work, you're targeting all over the place, from within the walls of the citadel of orthodoxy and also without the outside of the walls. So Tell us a bit more about who you have in mind when you pursue that liberation mission. Let's put it this way.
Well, I really have in mind both scientists themselves and, as you say, people outside the walls of science, because now there's an echo on my... Oh, is it all right now? Can you hear me okay?
I can, yes.
Yeah, good. Probably the main way this message has got across so far is through my TED talk, because in 2013 I gave a TEDx talk on the subject of the Science Delusion, and it was released again last year in an animated version, and the animated versions had well over 1 million views, and the original TED talk was censored because some militant materialist didn't like it. And as a result of that, it had well over 7 million views. So this message has reached millions of people. And most of them are not scientists or people who read about the philosophy of science very much, but everybody's influenced by it. You see, it affects all our lives. If we have the view that one of the dogmas is that nature has no purpose, the whole universal evolutionary process is completely pointless. It's just random chance governed by impersonal laws and chance events. And biological evolution, according to neo-Darwinism, is just a matter of chance mutations and natural selection. Then it's not going anywhere, it's not purposeful. It gives the idea that we're living in a meaningless universe, a pointless, meaningless universe. That's a terribly depressing point of view. All traditional religions and cultures provide a sense of meaning and purpose for human life. And I think it's not a coincidence that in the modern world, in the secular modern world, the endemic problem is depression. This worldview is intrinsically really depressing. We live in a purposeless universe. Gods, angels, saints are just imaginary beings inside human heads. That there's the brain is, the mind's nothing but the brain. Psychic phenomena don't really exist. When you die, it all goes blank. There's no higher values like truth, beauty, and goodness. They're just constructs of human culture and human minds, ultimately of human brains. This worldview, which has permeated our whole culture, everyone within it is influenced by this worldview through the educational system, which is the main way in which it's conveyed. And we've now spread this to the whole world. So people studying science, or indeed any kind of secular education in Africa, Asia, South America, anywhere, everywhere in the world, is being taught the same kind of thing. And if it's not true, which I think it isn't true, then this is terrible. It means the whole world is in the grip of an appalling falsehood and a misimagination. I mean, it's something that destroys the normal understanding in all traditional cultures of meaning and purpose and life and our relationship to other forms of consciousness, and replaces it with this pessimistic, dreary worldview. The only thing that's optimistic in it is the idea that through more science we'll get more technology and therefore more products and more economic growth. And that's, of course, good news in some ways, but that's what has really kept it going. The worldview itself is deeply unattractive. So I'm rather hoping that through the book itself, for those who read it, for the spin-off, like the TED Talk, which reaches millions of people who'll never read the book or do the course, at least opens the idea that these dogmas are not the ultimate truth. You don't have to believe them. You can be much freer in your thinking. And the course itself is really designed for people who want to go into this in more depth. And it can either be done by individuals who can then discuss it with their friends and family. And at the end of each chapter in the book and in the course itself, I mention questions you can bring up in discussions with your materialist friends, because all of us have materialist friends and acquaintances. They're, after all, probably a large minority or a majority of the population in most European countries. And there are many, many in North America too. So, and then really, I suppose my hope would be that this course would be used in schools and colleges. Each module is about 40 minutes long, and could be followed by discussion. It could be part of a science education program. I don't know of many examples where that's happened yet, but that's something I'd love to see happen.
Yes, beyond materialist adults and non-materialist adults, it's key to intervene before the minds of the young people are shaped into one direction. I was going to ask you, and I don't like playing devil's advocate. I never liked this expression, but the fellow who wrote the God Delusion, not the Science Delusion, would say that's all very nice, but we don't care if the view that science offers, the view of the universe that science offers, is depressing or not. What matters is if it's true or not. It's like the typical hardcore scientist t-shirt motto, like, just get on with it. We don't care about what's pleasing or not. Now, your movement here is, you said there are these dogmas which have hardened. Well, your movement is to liquefy those dogmas into questions, right? So would you say, of course, we don't really know what's true. We should be interested in it. Now, there are different alternatives. And at least you're asking, could we entertain the alternative? But more than that, because I think you're saying, and your work shows moves in that direction, that it's arguably more likely that the alternative is true than what we are usually told, isn't it?
Yes, exactly that. I'm a scientist after all. I am interested in what's true. I'm not a relativist who thinks you can never know the truth and every point of view is equally valid to every other. I certainly don't think that. I think some views are more correct than others. And I have a conventional view that in science, putting forward hypotheses and testing them by experiment is an important way of improving our understanding. So when it comes to the big questions that are taken as true, for example, the dogma that the laws of nature are fixed, the idea that the whole universe is governed by laws which were all there and constant, that were all there in a fully formed state at the very moment of the Big Bang. This is simply an assumption. No one was there at the moment of the Big Bang to measure laws and constants. And indeed, if there was a time machine, you go back to the Big Bang, since it's millions of degrees centigrade, any observer would evaporate long before he or she actually reached the Big Bang in their time machine. So it's not something we can actually know by direct observation. It's a simplifying assumption, and it's actually a carryover from the Platonic assumptions of 17th century science. The scientists thought the laws of nature were fixed because they were ideas in the mind of a mathematical God. Now, most modern cosmologists don't believe in God, but they still believe in eternally fixed mathematical laws. And instead, as you know, I propose that the laws of nature may be more like habits, that they evolve along with the universe. And this is testable through tests for morphic resonance or for habit formation in nature, in crystallization processes, in animal learning, in micro and low temperature physics, in many areas. It's a testable hypothesis. It has been tested, is being tested. It's not clear yet whether it's true or not, or closer to the truth than the eternal law idea, but I think it fits the facts better, and it's much more consistent with an evolutionary worldview. And so really my message is not that that's not true, this is true. It's saying it's an open question, and the two main possibilities are fixed laws or evolving habits, and we can do experiments and find out which fits the facts better.
Yes, let me stress here, and you know how much I admire you and your work and your stance, but let me stress here that apart from just calling out these dogmas and turn them into questions, which is a delightful, you could say, theoretical exercise, there are two things that you do that are interesting and valuable. One is, for instance, you were mentioning the idea that the laws may not be fixed software code, but more like habits. Well, this is a very profound and difficult idea. But you make it come across from the hardcore Whiteheadian scholars, if you wish, which may know what this means at a cosmological level, all the way to really lay people, and that's remarkable. That this can be understood, because sometimes these difficult ideas are really hard to come across. That's one thing. And the other thing is that you go and test them. You don't only say, well, you see, I think the universe could be that, not this, and that's my theory. You go, you're really genuinely interested in figuring it out through tests. And that's not to take for granted either, because the oscillation between being a theoretician and an experimentalist within the same body, it's quite difficult, and it's really important.
Well, I'm helped by the fact I'm a biologist. In biology, usually the same people are theoreticians and experimentalists. It's only in physics, really, that you have such an extreme division of labor, where there's a whole class of theoretical physicists with blackboards or whiteboards and pens and paper and stuff, and now computers. And then experimental physicists with gigantic apparatus like CERN, the Large Hadron Collider, or low temperature physics labs, or enormous vats of fluid in deep mines trying to find gravity waves and stuff. Those are more like engineering projects. So physics is unusual, I think, in its division of labor. In biology, certainly when I was growing up and being educated in biology, there were almost no theoretical biologists separate from experimenters. There's always been a journal of theoretical biology, but it contained complex mathematical models that most biologists couldn't understand and had almost zero impact on biological research. Maybe it has more now, but certainly when I was doing empirical research at Cambridge or in agriculture, it had almost no impact. So personally, I've always been an experimentalist, and I love doing experiments, and I love designing experiments. And I've always enjoyed doing experiments simply and inexpensively, partly because I was brought up in the British string and sealing wax tradition, where most researchers worked on very small budgets. In Cambridge, I shared a lab with Robin Hill, who discovered how photosynthesis works, the so-called Hill reaction of photosynthesis. And he made all his own chemicals, dyes, to absorb light at different wavelengths. And he identified them with a hand spectroscope he kept in his pocket, and then he'd hold up a tube of the compound he'd just made and work out its spectrum by looking at just the dark lines. And this, you see the spectrum, and you see the dark lines, the hand spectroscope. And his annual expenditure on his equipment budget was about £200. I was a graduate student, and I was a research fellow, and I had equipment and allowance in those days. It was a long time ago. I had an allowance of about £200 or £300. I spent about £300, but he spent less than me, and he was a full-time researcher at the leading edges of science. He made his own apparatus, synthesized his own things, did everything very simply. And that tradition was forced on a lot of researchers because there just simply wasn't much money for scientific research. When I worked in India in an agricultural institute, I had to do research in the field because agriculture is all about crops growing in fields. And most of my research assistants were illiterate. So I had to simplify the experiments so they could be done by people who couldn't read or write. And so it was an exercise in simplifying science and finding ways of doing sophisticated experiments with very simple methods. So I've always liked that approach. And indeed, it's been forced on me, indeed, for the last 20 or 30, 40 years, because the work I do is unconventional. It's very hard to get grants for unconventional science. And I have a couple of wealthy patrons or sponsors who very kindly supported my work on a modest scale. But even so, I have to do experiments very cheaply. And I myself think that this is also an aspect of holistic science. If you're doing research on holistic science, you're studying things at their own level, rather than trying to reduce them to the smallest possible thing. The smallest possible thing are subatomic particles. And ironically, to study the smallest possible things in nature, you need the largest possible equipment, like the Large Hadron Collider, 10 kilometers across. Whereas if you want to study the mating behavior of a blackbird, for example, all you need is a pair of binoculars and a clipboard and some paper and possibly a camera to film it. So if you study things at their own level, it's usually cheaper. And the whole point of the kind of science I'm discussing in my course is a much more holistic kind of science.
Yes, in that respect, let me also say you're a pioneer of what's called now citizen science, by necessity, as you briefly alluded to, right? But also very deliberate. You've proposed experiments that people can do or people can contribute and send to you, and this is, well, this is fun, this is engaging, and this is important. Not to say that laboratories aren't necessary. I mean, it's a great invention. What a laboratory is, even conceptually, it's quite of a special place, as Bruno Latour said, where it's a place where facts are manufactured, are produced in a good sense. No, and now it comes out of the lab and it's a fact. But the idea that, let me put it poetically, maybe that the entire world is a laboratory, it's both, again, beautiful and powerful.
Yes, it depends what you're trying to study, of course. If you want to study the Higgs boson, you need the Large Hadron Collider. But most people aren't that interested in the Higgs boson and don't really know what it's all about. But most people are interested in plants growing in their garden, the way their children are growing up, their own minds, social relations, the behavior of their pets and their animals. And a lot of my research on animal behavior, as summarized in my book, Dogs That Know When Their Owners Are Coming Home, was done with dog and cat owners and other pet owners. And if you want to study the telepathy between a pet owner and their dog or their cat, then it doesn't really help to put the dog or cat in a laboratory and sort of pin it down on an operating table and stick electrodes into it. It's much better to just observe it in its natural conditions and see what it does and film the behavior on camera. You need objective records, not just people's subjective impressions. But filming is cheap now, and easy to do. And so a lot of this research can be done in natural environments. And again, this is something I learned through working in agriculture, because agricultural research is done in fields. And there are perfectly good scientific ways of doing agricultural research. Statistics, as we now know it, was basically invented by R.A. Fisher, who was the agricultural statistician at the Rothamsted Agricultural Research Station here in Britain. And these statistics that are used in agriculture and in clinical trials and in epidemiology, all these kind of statistical methods were really developed to deal with real-world science in the first place.
There is something quite invincible about this approach, and I think once we were joking seriously that there's nothing that outrages more a proper academic than a telepathic parrot or a telepathic dog, right? And at the same time, lay people absolutely love it. Because they may be experiencing that something along those lines is going on. So why not check it?
Well, exactly. About 50% of dog owners have dogs that know when their owners are coming home. That's millions of dogs. Hundreds of millions of dogs. If you take Europe and the Americas and Asia and so, I mean, it's happening every day. It's not some obscure, rare thing. It's terribly common, and most people are interested. Telephone telepathy occurs to about 85% of the population, thinking of someone who then rings. These things interest people because they experience them, the sense of being stared at. About 95% of people have experienced that. And a lot of people are interested in birds. The most popular nature charity in Britain is the Royal Society for the Protection of Birds. It has millions of members. And these are not professional ornithologists who have careers in classifying birds. They're people who just love watching birds, believe in protecting birds, feed birds in their garden, have pairs of binoculars, identify birds when they go out for a walk. There are a lot of people who are really, really interested in these things, and rightly so. And children, of course, are interested. Many children are interested in these things. In British schools, unfortunately, it's assumed that actual contact with nature is just for the youngest children. in nursery and reception classes, when my own children were at school, they had something called the nature table, where people could bring in things they'd found, like feathers or birds' nests that had sort of fallen out of a tree, or things that or jars of tadpoles and things. They had the nature table, but by the time they in year one, 5 or 6 year olds, and year two and so on, then biology wasn't about nature. It was about the heart is a pump, the brain is a computer, how your body works, textbooks showing the body as a machine. And again, they instead of taking children outside to look at stars, the science education was textbooks of diagrams of planetary orbits and spaceships and that kind of thing. So I think that most people are really interested in these things, but the educational system assumes that kind of interest in actual direct natural phenomena is just for the tiniest kids, and grown-ups really should be thinking in terms of mathematical formulae or reductionistic explanations. It's a great shame, but most people the advantage of these working on these topics is that large numbers of people really are interested, with a genuinely scientific curiosity, much greater than that shown by many scientists, or at least when they're at work. Because although at work a lot of scientists may ignore dogs knowing when their owners are coming home, as I found by talking to scientists myself, quite a lot of them have dogs that know when they're coming home from the laboratory. So in their private lives, most scientists are normal people, and have all these experiences themselves and are often curious about them, but they've learned this is not something you discuss with your colleagues in the laboratory setting. You might discuss them in a pub in the evening, but not at work.
Yes, and not only are they interesting, they're genuinely interested, but again, these questions are foundational to science. It's not because democratically people care. Not only that, if we go back and maybe we can discuss a few of these dogmas turned into questions, but they are genuinely at the cutting edge of our understanding of nature. So both things, again, there's this overlap between what people naturally really care about and what we scientists would naturally or should naturally care about, because that's the edge of our knowledge, and supposedly that's where we're trying to expand. But before that, let me ask you, let me come back to dogmas themselves, and then maybe we can discuss some of these of the list. And it's not any list. Every one of them could take us a long time, and actually that's why I suppose people who take the course can enjoy them more slowly. Your reflection on dogma, if we try to empathize, like dogma seems to me, and dogma in science, because next I'll ask you about dogma in religion, but dogma in science seems to be just a symptom of insecurity based on a false idea that science has to provide all these certainties. And so I'm not going to be doubting about fundamental things. Otherwise, what's people going to think about me? Like when they call the scientist on the stage, people usually want answers, or we're presented this portrait of the scientist as he or she who provides answers, and then questioning not just the answers but the very questions puts us in a vulnerability situation, which is where fruitful science takes place. So any reflections about an understanding of why dogmas are there?
Well, I think dogmas are there because they're habits. And I think all systems need habits. I mean, as part of my own theory of morphic resonance, the amount of that we can think about in consciousness is very limited. We can't think about most things. We just work habitually. We're all creatures of habit. And so, we have all sorts of physical habits, like, if you know how to drive a car or ride a bicycle, you just do it. You don't have to think about it. I'm a pianist, and so I can just look at a piece of music and play it on the piano. I can sight read it. The habit, I don't have to work out that's an F and that's a G sharp and this finger does that. It just automatically does it. It's a habit. And the same with our thinking. We have to have habits of thinking because we can't examine every assumption all the time. We just haven't mental capacity in our conscious mind to do that. So I think that dogmas are, in a sense, simplified habits of thought. They're necessary. That if you're going to teach science to, someone in year 3 or year 5 or something, you can't necessarily bring up all the possible counter arguments. There's certain facts, like how far the sun away is from the earth, which order of planets there are as you move out from the sun, the anatomy of dogs, cats, and other animals, hearts and lungs about air and exchange of air and oxygen in the blood. And so there's a lot of things in science which are purely factual, and which and ways of doing science which are kind of become habitual. Heat things, put a heat on something, it gets hotter, you measure it, the temperature and all that. The problem comes when these habits of thought are treated as fixed truths, and it's hard to break habits. I mean, it's true in our own personal lives, and it's true in our collective life, collective habits, and it's true in science. I think what makes science different is its ideological claim that everyone else has dogmas, religion, politics, political parties, etc. But science is the arena of free thought and critical thinking. Scientists like to think that they are uniquely objective and uniquely able to think freely and clearly compared with everyone else who's bogged down in relativistic assumptions, opinions, prejudices, superstitions, and so forth. So the self-image of science, part of the rhetoric, the propaganda that was used to establish science as a social movement, especially in the 19th century, well, it came from the Enlightenment, putting science the top of the whole human endeavor, relegating religion and indeed the arts to a lower level, mere products of human subjectivity, whereas science is about the understanding of the whole universe, the ultimate truths, and for the founders of modern science in the 17th century, the mind of God, because they thought these mathematical laws were ideas in the mind of God, and that scientists were uniquely privileged to see into the mind of God and indeed participate in it. Well, in the 19th century, as organized science came about, it wasn't done by huge institutes until the 19th century. And when people like T.H. Huxley were trying to establish science as a professional activity, with scientists as professionals, paid professionals, then they had to emphasize how superior it was to all other forms of knowledge. Well, this started with Bacon in the 17th century, Francis Bacon with his vision of the New Atlantis, where a scientific academy at the forefront of discovery. The scientists were like a new priesthood, and therefore they had to elevate themselves above the old priesthood of religion by these claims that they had a superior objectivity, a superior access to truth, and so on, which I think has led to an enormous amount of self-deception within science, and means that many people can't see that science, like everything else, has habits of thought which are dogmas, which may or may not be true.
I really like this metaphor, and maybe it's more than a metaphor between habits and learning to play the piano or drive and dogmas. When this crystallizes and you forget, you have some sort of amnesia that a habit has been created and you cannot get out of it. But now let me ask you then, is there a place for dogma in religion, and is there a place for dogma in science?
Yes, I think there is. The dogmas in religion, the point about religious dogmas, particularly in the Roman Catholic Church, is they're actually called dogmas. This is the dogma of the Immaculate Conception or something like that. There's no attempt to pretend it's not a dogma. They say it is a dogma. A dogma is a doctrine which is generally accepted. So one of the dogmas in Christianity is that the nature of God is the Holy Trinity. There's a Trinitarian nature to God. And the creeds, the Apostles' Creed and the Nicene Creed, are both basically statements an unwrapping or unpacking of that dogma, explaining the reasons for it. So it's not just a dogma. The creed actually sets out the nature of this Trinitarian aspect of God. And when people recite it in church services, they're probably not thinking about it very much. But if they do, then it gives reasons for the dogma, the underlying arguments, as it were. So I think that, and if you're teaching the Christian religion or the Hindu religion or the Muslim religion to sort of 5-year-olds, 6-year-olds, to children and to students and so on, then again, you can't unpack every single assumption of the whole system. It would take years of education to go through all the arguments for and against. And I think the same is true within science. You have to teach science where, as if these things are known, but it doesn't mean to say they really are known. And if we're going to teach science as dogmas, then it's better to have dogmas that are true rather than false. If the laws of nature are not fixed, and if they're more like habits, it would be better to teach that in schools. Science is made up of evolving habits, and things go on much the same most of the time because they're habits, and there's a kind of memory in nature. It'd be perfectly possible to teach that just as easily as to teach that the laws of nature are fixed. What Thomas Kuhn pointed out in his famous book, The Structure of Scientific Revolutions, is that at any given time, science works within a paradigm, a model of reality, which comes equipped with a full set of dogmas, and that you need that framework to function within what he calls normal science, filling in the details. I mean, is this enzyme activated more by calcium or by magnesium ions? That kind of research, it all happening within the established paradigm. But the scientific revolution is when the dogmas are challenged and changed, and when a whole new model becomes established. In due course, that turns into dogma as well. But so in that sense, scientific dogmas are not unlike all kinds of dogmas, all kinds of assumptions, all kinds of culturally transmitted patterns of belief. And the only difference is that scientists aren't aware of it, whereas everyone else is. Everyone who's a Christian or a Muslim or a Hindu knows that their position is a position of faith, that it's a particular worldview that's culturally shared with other people in their religion, but people in other religions have different worldviews, and people with no religion, atheists, have a different worldview again. Whereas in science, it's assumed that this is the only conceivable rational worldview which would apply to everybody in the entire world, in every culture, and that it's somehow risen above dogma and has reached this whole new level of truth. That's, I think, the worst illusion of science. It's pride, if you like. The pride is the root of all evil, many people have said, and the sin of pride is baked into science as we know it, largely through this Enlightenment propaganda that science is the one true way of knowing the world. And this leads to its own kind of religion, which is often called Scientism, making science into a kind of religion.
Yes. This helps me understand better the title here, the word delusion, and maybe rephrase, let's see if I get it right, that you haven't questioned so much religious dogma as opposed to scientific dogma, because scientific dogma is a very particular kind of dogma which pretends it isn't. It is the biggest sin of science would be to be dogmatically religious, pretending it is the actual opposite of that.
Yes, I think that's the case. I myself have spent years as an atheist, and I did have, like most people in a modern secular society, make a critique of Christian and other religious dogma. But usually it was, in my case, a pretty uninformed critique based on kind of standard atheist propaganda. It wasn't a deep understanding. It was pretty superficial. but I think religions are in a better position precisely because they're pluralistic. You know, I'm an Anglican, so as an Anglican Christian, you know, I know that in Hampstead where I live, there are Roman Catholic Christians, there are Pentecostalist Christians, there are Baptist Christians, there are Methodist Christians, there are Greek Orthodox and Russian Orthodox Christians. There are many kinds of Christians, and then there are Muslims and there are Hindus and there are Sikhs and there are Parsis. But if you're in a science, you don't have any sense of pluralism at all because it's all the same, and there isn't an idea that there could be different worldviews. So anyone in religion knows that this is not the only universal truth to which all people ought to assent. A few very militant fundamentalists may think that, but most people don't. Whereas in science, it's not the same.
I wasn't planning on talking too much about religion, but let me just ask you one more. Do you think, and that's you personally, but also in general, that religious people think that other people of other religions are wrong? Because that's also an idea that's baked into our understanding of religions, that if you're a Christian, then you by default must think ultimately that other religions are fundamentally wrong, because otherwise yours wouldn't be the true one. So how to make religion pluralistic in a way that doesn't destroy what seems to be a core aspect of what we're taught about religion?
I lived in India for 7 years, and India's always been pluralistic religiously. You know, within the Hindu world in India, there are Shaivites, there are Vaishnavites, there are wandering sadhus and sannyasins, there are monasteries, there are temples, there are holy men, hermits living in caves. You know, there's all kinds of religious practice within Hinduism. And then there are Muslims, there are Sunni and Shia Muslims, and there are Sufis. And then there are Christians, St. Thomas, Syrian Orthodox Christians in South India who've been there for nearly 2,000 years. Then there are Sikhs, and there are Parsis, and there are Jains, and others as Buddhists. So in India, all of the traditional view, before Modi came along with this rather divisive Hindu nationalist politics, the traditional view in India has been just living alongside people with different religions. And within Hinduism, if you're a Shaivite, you don't say Vaishnavites are wrong. You just say that's another way of seeing God. And the thing that Christian missionaries in India found most frustrating was that they'd go and talk about Jesus and say all the virtues of Jesus, his wonderful teachings, and that he's the Son of God. And Hindus say, yes, very good. Yes, Jesus is the Son of God. And he said, rather like Krishna, you know, and like other avatars and Buddha and stuff. And they say, no, not like those. So Hindus say, well, why not? You know. So their problem was the problem of the Christian missionaries was that there really was this general openness. Indian Muslims, on the whole, when I was living there, tend to be open. They've now been sort of evangelized by Saudi Arabian missionaries and with much narrower, more dogmatic, more fundamentalist kind of Islam. But I would say that most people, the dogmas of religion in the Protestant Reformation in Europe, the problem really was about which religion has the state power. And the Reformation in England was about who controls the church. It wasn't primarily about religious dogma. The king wanted to be in charge rather than the Pope. And in Germany, where there were some Protestant states, some Catholic states, the religion of the ruler was the religion of the state. And it was much more about political power and control than it was about exact theological disputes.
Yeah. What you just
were referring to, of pluralism is deeply embodied. Oh no, and Muslims, on the whole, are quite friendly, as I found living in India, to Christians and to Jews, because they say they're all people of the book. They all share the same ancestral roots of their vision of God. So there's a sense of being cousins in religion rather than enemies.
Yes, and your description reminded me of a Monty Python sketch, actually. And then in talking with John Cleese, he reminded us that one thing is to be serious and another thing is to be solemn. And there's this solemnity, which is probably the problem. So you've mentioned pluralism, holism. Let me just briefly mention the list of dogmas, because we won't have time to, obviously, time flew as I supposed. But that's another thing I want to emphasize about them, which is that they're not grumpy. So that's another aspect of your way of working, which is not just like I'm denouncing these things and I'm just so angry about it, and what I propose is kind of again grumpy, which is quite of what we hear sometimes with the elites of the public understanding of science. And all these questions are just simply fascinating, makes one's heart sing and smile. And so let me read them and also emphasize another thing that I realize it's obvious, it's hidden in plain sight, that you're just asking about the adjective that goes with each of those core aspects of nature. For instance, is nature mechanical? That's one. The laws fixed. Matter and energy constant. Matter unconscious. Nature purposeless. Inheritance material only. Minds confined. Memories stored. Psychic phenomena illusory, and mechanistic medicine the only one, right? So again, the technique of liquefying the dogmas and then just acupuncture touching on these adjectives and saying, well, what happens if we turn it around? And by the way, and maybe this is a way we could start wrapping it up before Q&A, some of those ideas with the years are being more and more liquid, right? Because we read now from heterodox, not heretic, but heterodox biologists, for instance, that living beings have agency. It seems to point to, well, it's nature purposeless. Well, if living beings have agency. Now in consciousness studies, well, panpsychism and idealism and other isms are questioning that matter is unconscious, for instance, or the extended mind would be another current field of research where this heresy is porous to the heterodoxy and maybe reaching the orthodoxy. And so maybe you could reflect on some of the changes that you see happening, especially because you mentioned that in the course you talk about the status of these dogmas today. And it's so interesting to see in a few years what may have changed.
Well, to take one of those examples, panpsychism, the idea that there might be some kind of mind or consciousness or experience in matter at many different levels, atoms, molecules, crystals, and even stars, galaxies, and the whole cosmos, as well as living organisms. This is indeed, as you say, growing. I mean, there's now a rather surprising growth of panpsychist discussions within philosophy of mind and within consciousness studies, partly because of the hard problem, the problem of explaining why we're conscious if the whole universe is made of matter and matter's unconscious and there's nothing but matter. We ought to be unconscious too. So the very fact we're conscious is a serious problem for materialism, the hard problem. And so some materialists like Galen Strawson are trying to solve the problem by saying, well, give a little bit of matter to atoms and molecules, and then it's only a difference of degree, not of kind. So that argument is now quite widespread. And so that has been a distinct change. Since the first edition of this book came out in 2012, the panpsychist argument has advanced quite considerably. Then the dogma in 2012, it was still the leading dogma that all biological inheritance is, or nearly all of it, is in genes. It was still very widely accepted, but already the growth of research on epigenetic inheritance had begun by then. And now it's got very, very much more. And it's now widely accepted that in acquired characteristics in behavior or adaptation can in fact be inherited. Epigenetic inheritance is now a major field of biological inquiry. And this in turn has had the knock-on effect of meaning that evolutionary theory, which under neo-Darwinism of the Richard Dawkins selfish gene type, was all about gene frequencies in populations, where natural selection changed gene frequencies in populations. It was all about gene frequencies and selfish genes. Well, now the missing heritability problem it shows that actually the genetic program, the genome just doesn't code for most things that are inherited. It only explains 10 to 20%, in some cases only 5% of what's inherited. I discuss this in the course, of course, and with examples. And so we now have to have what's called the extended evolutionary synthesis, which is a much broader, much less doctrinaire, much less shrill than neo-Darwinism, and actually, ironically, closer to what Darwin himself argued, because Darwin was quite an inclusive thinker. He was not a narrow ideological, dogmatist. He was a very admirable scientist, one of my heroes. And so the extended evolutionary synthesis is much more inclusive, like Darwin himself. Neo-Darwinism distinguished itself from Darwin by its single-minded emphasis on genes and almost exclusively genes. And then in other areas, like one of the parts of my book is on illusions of objectivity. In 2012, I was pointing out that most scientists only publish their best results, that although they think they're supremely objective, there are all sorts of factors that make the practice of science not very objective at all. And I more or less predicted that most scientific papers, even in respected journals, would not be reproducible for these reasons. Then in 2015, the reproducibility crisis burst in science, and it turns out that in biomedicine, up to 90% of papers in top journals can't be reproduced. In psychology, about 60%. So in many fields of science, most published work can't be replicated because of in biases within the scientific process itself. And when I was trying to point these out, people just thought this was, just absurd. I was just sort of making pointless criticisms about something that was so well established, so generally agreed, there was nothing wrong with it. Now it turns out the whole edifice is a house of cards. And so there are various ways in which some of the arguments I made in the original version of the book are now much, much more mainstream. I would say even the dismissal of psychic phenomena as illusory is less vehement than it used to be. There are still hardcore skeptics who dismiss them all, but it's harder and harder for them to criticize the growing body of evidence. Their main argument now is that they're simply impossible on theoretical grounds, so there's no need to look at the evidence. And most people rightly see that as a position of prejudice rather than reasoned argument. And then a subject on which you and I have written a joint paper, the idea that the mind's confined to the inside of the brain, the mind's inside the head, has given rise to a much wider discussion on the extended mind, the way that minds might be extended far beyond our brains in every act of perception. So at least visual perception and auditory perception. So I would say that things are moving in the general direction in many areas. Within cosmology, the cosmologist Lee Smolin says, well, maybe if there's an evolutionary universe, maybe the laws of nature aren't fixed. Maybe they're more like habits. Well, I've been saying this for years. Well, now here's a cosmologist saying it. So I would say that the debate is generally going almost entirely in the direction this course sets out. So I think it's not just a critique of what's going on in science in the past or of established contemporary science. In some ways, I think the course might help to open people's minds as to new possibilities which are actually already happening, that there's a kind of revitalization of science, a kind of scientific renaissance is possible, and it's already beginning through these questions being opened up and through them being explored in new ways. A bit like the banning of psychedelic research for 20 or 30 years, set things back. But now there's all this psychedelic research going on. Ideas about the mind, the nature of the imagination, the nature of subjective experience are rapidly changing because more and more people are having experiences that change the old idea is just mechanistic processes inside the brain. So in all sorts of ways, I think there's an opening up going on at the moment.
Indeed, and if we zoom out, we see there's a rhythm, because these things come in and out of fashion or of important, and also I suppose the course and the book and this conversation we're having are reminders. And borrowing your image of Dogmas as habits, well, it's like you're playing and you're always playing the same thing. From time to time, it's good to try to improvise and inject some creativity into the business, and then maybe just transform it into a habit again. So it's never a bad idea to listen to these opening possibilities. Let me also say before finishing, and that's another praise to you, but I cannot help it, which is that it's important when people predict all sorts of important things and they turn out to be right. And also let's bear in mind that, for instance, the idea of the extended mind, which was more or less always there, but you coined it in, I think, 94. And then it became famous, but in its vanilla version, as I say, in philosophy, or the replicability crisis, where you have already, as you just told us, anticipated, predicted, articulated, and then, of course, and the idea that all inheritance cannot be, material or gene-centric, and then epigenetics, so there must be something in you, and now I'm underlining your temperament that allows to still be better, not bitter, while realizing that you've said this all before, and then people have said no, and then people have said it in their own ways, in a kind of watered down way, and claim this is big news.
Well, that certainly happens, and people don't, when people write academic books or papers, even though they're much influenced by views I put forward, they don't put me in the reference list, because they know that it might run, because I'm so controversial and been branded a heretic, that it'll cause problems with peer reviewers or PhD examiners and stuff. So I'm selectively filtered out of these things. But actually, I think that's just part of the process. You see, I think part of the process is that you have to open up the possibilities, make it safe for other people to develop them. If ideas are going to spread, they have to spread through multiple people putting forward these ideas. And people have more incentive if they get the credit for it. One of the, I think, perhaps one of the only memorable saying of President Ronald Reagan was that, it's amazing what you can achieve in politics if you don't care who gets the credit. If people have a personal investment in some of these areas and get credit for doing it, they'll be much more motivated to do it. It doesn't really much matter to me in many areas. I haven't got a promotion committee working on my case, and since I'm self-employed, I don't have to worry about all the things that people on the academic career ladder have to worry about. Thank goodness. So it doesn't matter. But if your whole career depends on getting credit and stuff, then it's much more of a personal issue.
Well, there's ego anyways in all of us. We run out of time, but one last reflection could you make about the last, I think it's the last episode, let's put it this way, of the series, of the course, which is scientific futures. And I would like you to comment on it from an evolutionary point of view. And if we can get a bit grandiose in this last question about the evolution of mankind and maybe the evolution of spirituality, all entangled with scientific futures.
In 30 seconds?
Yes, or 20. No, come
on. Well, I think that basically the opening up of these questions in science would have all sorts of ramifications. I think partly it would enable us to see that the way that traditional cultures have been dismissed by science and by Western educators has been completely biased and dogmatic. Most traditional cultures in the world, shamanic cultures and most others, are animistic. They believe that nature's alive. Now, with Panpsychism, in Western science, we're coming to the view that nature's alive. And there's a lot we could learn from shamanic cultures. In fact, there's a lot we already are learning from shamanic cultures where people have had spiritual practices which treat animals and plants as alive instead of mere mechanisms, unconscious mechanisms. So one is opening up to learning from traditional religions and spiritual practices, which tell us something about human nature, about consciousness, and about the nature of the universe and our relationship to it, instead of just throwing the whole lot away as saying this is meaningless superstition or mumbo jumbo. It's been the attitude for a very long time. So a kind of new humility and willingness to learn from others. I think a pluralism in science, which would have to come from pluralistic sources of science funding, because if you only have central government funding bodies, which are committees controlled by influential scientists, then you'll get more of the same. You'll get incremental improvements. Existing science is set up to deliver incremental improvements on existing patterns. There's a real chance of pluralism, partly because if governments in different countries see they don't have to follow a standard model, if the government of India says, well, let's back Indian science, let's understand more about yoga and breathing and pranayama and how people can affect human physiology, instead of just leaving it all to people in London and New York who are basically into molecular medicine and will never ask these questions, or the Chinese government. They already fund research on acupuncture and Chinese traditional medicine. There's a lot we could learn from this, and it's not funded in the West. So pluralism, there are not lots of billionaires, and some of them are interested in science and can provide independent funding sources. So I think all of these are ways in which scientific futures and a wider participation of the public in scientific research, changes in scientific education that cease alienating people from the natural world and indeed from science itself by making it seem dreary, boring, and life-denying. There are all sorts of ways in which scientific futures could be different from the way it is at the present. And that's one of the things that I explore in the course.
Wonderful. Thank you, Rupert. As always, it's a blessing to be in conversation with you. Thank you very much.
Thank you both, Àlex and Rupert. This was a wonderful conversation that the two of you had together. And now it's time to open it up to the rest of the group. There are a lot of us here today, so I do ask you to please keep your questions to the point. And we will now open up. Glenn, please come in.
Hi, can you hear me?
Yeah.
Oh, good evening. Thank you for the very nice talk. As the PARI Center, which is the forum here, is at least in part dedicated to David Bohm, and I guess in somewhat of a connection also to J. Krishnamurti. And as I know from YouTube that dear Dr. or Professor Sheldrake, you've participated in the dialogues of Krishnamurti and Bohm. I am curious and would like to ask, what is your take on what was discussed in dialogues? I mean, for me, it's always been a question about, you know, where has humanity maybe gone wrong? Has humanity taken a wrong turn? What is the fundamental underlying process that has brought humanity to a certain point of crisis? And so I wanted to ask, you know, your synthesis of the dialogues and how it has affected your life.
Okay.
And if there is time in a second question, I would like to ask something about homeopathy, but the first question is more important to me. Thank you.
One to start with, yes. Yes, I had this whole series of dialogues with David Bohm and with Krishnamurti and Bohm, and some with just Krishnamurti. In the early 1980s, Krishnamurti was traveling around the world teaching in India in the winters, in England in the autumn, and in California in the spring and summer. And I was doing that too. I mean, not because of him. I just happened to be working in India in the winters in agricultural research as a consultant in England in the autumn, and I spent May or June in California. So we overlapped, and for several years we happened to be traveling around the world, and we had these dialogues in these various places. Some were filmed, some were not. With David Bohm, who I met through Krishnamurti to start with, I also had private ones. We both lived in North London, and so basically for David Bohm, the ones that with Bohm are mainly about the relation of morphic resonance and what he called the implicate order, the way in which there could be habits and memory in nature, and how this could relate to quantum theory. These were very helpful dialogues, and one of the main ones is reprinted as an appendix in my book, A New Science of Life, called Retitled Morphic Resonance in the United States. With Krishnamurti, he had this idea that the world's got into a terrible state through the divisive nature of thought and the separative nature of our mental activity. He was very good on saying what's gone wrong. He wasn't so good on saying what you can do about it. In fact, he left a lot of people floundering because he dismissed all religions and most spiritual practices as useless. But he didn't really offer people very much instead, except the idea that enlightenment could happen immediately, that the potentiality is there all the time. And I suppose one of his central doctrines was that we're all interconnected. He used to say, I am humanity. Something that happens to me affects other people. So he really liked the idea of morphic resonance because it gave a kind of scientific basis for a lot of his teachings. And one of his teachings was that, if someone becomes enlightened, then the whole of humanity becomes enlightened. So in some of the dialogues, I'm afraid I teased him a bit because some of his followers were he used to say, I'm not a guru, I'm just, let us discuss it together and so on. But actually, in practice, he was a guru for a lot of people who went year after year to hear him talk. And so some of them the reason I had so many dialogues with him was that some of his followers egged me on to do this because they knew I'd ask questions that they didn't want to ask themselves, because I wasn't frightened of him. A lot of people were. I got on really well with Krishnamurti, but in a way that I felt I could speak freely. I mean, he said that's what he wanted, and I tried to do exactly that. So, for example, when he said, if one person becomes enlightened, all humanity becomes enlightened, I said, well, obviously no one's become enlightened yet in that case, because you've just told us what a terrible state the world's in. So then he said, well, maybe it has to be more than one. I said, well, how many? 10, 100, 1,000, just a rough figure. And he'd say, well, 100. I said, well, you've been teaching for all these years, and so it looks as if not even 100 people have. He said, well, maybe 1,000. And so, anyway, we had discussions like that, which were sort of rather playful, and but did go to the core of some of his teachings. And I think one of that teaching of his is important because it says that, it's actually true in all religious traditions, the idea that some change that can happen in one person can open the way for others. It's certainly a key teaching in Christianity. Christ is the way, because he opens the way for others to follow, and morphic resonance would help that process to happen. And so I would say that the discussions with Krishnamurti were really ones that helped clarify some ideas about science and consciousness, and with David Bohm were mostly to do with the nature of consciousness as it related to physical processes. But I think the thing that really was most important to me about the Bohm aspect, as I mentioned, was the idea that morphic resonance and quantum theory could be compatible in a way that he sketched out in his own way through the implicate order.
Thank you. Thank you, Glenn, and thank you, Rupert. Mike, would you like to come in?
Rupert, I'm thinking when I hear you speak and I listen to your view of science, I think immediately of David Bohm, because you're saying basically the same thing about scientific laws as David Bohm said about causality, and there's not too much difference there, I don't think. And when I say that, I also think of the relationship of Kant and Bohm. And you pick up on that theme in a sense when you ask us to look at the mind and habitual patterns in the mind, and so on. And I'm just wondering if you'd like to comment on that from an historical perspective, and also, well, yes, from a historical perspective, and how that has influenced you.
You mean Bohm's influence, which, well, I've just talked about Bohm.
No, Hume. David
Hume. Sorry, Hume.
Yeah.
Oh, Hume. Well, I read Hume when I was studying philosophy at Harvard when I was 21, and I found Hume, lively and stimulating. But his critique of his critique always seemed to me somewhat jumbled. He'd say he's proved causality doesn't, or at least it's just an idea in our own minds. Most of our ideas are just habits, and he's a sort of radical skepticism about most of our own experience. But then, as he says, when I put down my pen and go to join my family for dinner, I revert to my usual views and the conventional views. So Hume wasn't able to carry through his philosophy into real life, and I mean, he says so himself. And I think that his what he was doing was, well, he was deconstructing a lot of the standard assumptions of the time, and he was quite wide-ranging. For example, he said, why should it be? In his dialogues on natural religion, he said, why should we take it for granted the world is a machine, taking the mechanistic assumptions of science? Why not see it as an organism, the universe as an organism, like the Greeks and the Romans did? And he said it seems to fit the facts much better. So Hume was a radical thinker, but he didn't leave behind him a kind of coherent program. Then Kant came along, as you mentioned, and said, well, time, space, and causality are the only way we can actually conceive of the world, that we have to see things through the lens of time, space, and causality. We can't ask, does causality exist or not, because we can only understand things in terms of it. We can't say, does time or space really exist, because they're the conditions of our understanding and experience. And so he made the whole thing very subjective, and so we can't understand the thing in itself, nature in itself. Well, most scientists just ignored Kant. It had very little impact on science, because most scientists then as now believe there's a real world out there and we're understanding about the real world. It's not just all about our own minds and ideas and thought structures. So
I think Niels Bohr, was a Kantian.
Pardon?
I think Bohr was a Kantian with respect to quantum physics.
Might have been, yes. That would put the quantum theory interpretation of making it more subjective, the uncertainty we can't know and just calculate. Sort of. Most scientists aren't, though. Most scientists are naive realists. And Kant's had very little influence on the process of science. I myself think that we are conditioned to think in certain ways. Kant's right about the categories of understanding. But the traditional view was that the traditional in St. Thomas Aquinas, for example, if we go back to medieval philosophy, medieval Christian philosophy, the reason we can understand the nature is that our minds work in a similar way to nature because they both have a common source in God. And since God creates nature according to divine principles, and our minds are also, our consciousness is also derived from divine consciousness, the natural harmony between minds and nature is God-given. I think, personally, I think that's a better answer than saying nature is utterly obscure, the only thing we can think about our own minds. And in evolutionary terms, there are those who would say that the reason our minds are so adapted to understanding nature is precisely because through evolution, only minds that understood it fairly accurately would survive. Anyway, it's a big question, and probably we can't go into it much more.
Thank you. Thank you, Mike.
Welcome.
Ruth Ann, would you like to come in? You're still muted.
Can't hear you.
Okay.
Yeah, no, we can.
Okay. Thank you so much for this. I really appreciated your reflections about the sort of climate of depression that it seems has resulted from this sense that the world really is mechanical and meaningless. I'm a psychotherapist, and I have noticed so much depression and anxiety in my clients that seems to be associated with a sense of being estranged from most of what carries meaning. And I also noticed the similarity. I'm reading right now Stephen Harding's book, Gaia Alchemy, and he talks also about how the traditional scientific temperament was so depressing to him, and he had to go in a different direction. So thanks. I also wanted to ask you about panpsychism, and if I've noticed so much interest lately in the Gaia hypothesis. It's kind of a resurgent theme. And would you consider that a panpsychic vision of the universe?
Well, the Gaia hypothesis, when it was first put forward by James Lovelock, was specifically about the Earth, treating the whole Earth as a living organism. He didn't critique the standard mechanistic view that treated all stars, galaxies, and other planets as dead and inanimate. In his version of it, there was just Gaia that was alive, and the whole of the rest of the heavenly bodies and the whole of the rest of nature remained as before, dead, inanimate, and mechanical. And he was trying to be conservative in the sense that he wanted people to accept his idea and probably didn't want to go too far too fast. But it's limited, you see, and I think if the Earth is a living organism, which I think it is, then I think the other planets may well be, and I think the Sun may not only be alive but conscious. I wrote a paper called "Is the Sun Conscious?" It's in the Journal of Consciousness Studies just 2 or 3 years ago. And if the Sun's conscious, then maybe other stars are, and maybe whole galaxies are conscious, and maybe the whole universe. And it's, you see, we've one of the things we've got at the moment is this cerebrocentric view of consciousness. Consciousness only happens in brains, and only happens to the largest degree in big brains. So we're the most conscious beings in the universe, and the elephants and whales have big brains too, so maybe they're conscious too, but not as conscious as us. And so the standard worldview is that everything else in the whole universe is unconscious and inanimate, and it's only in brains that it's emerged. Whereas the traditional panpsychism, you know, in people thought trees, animals, stars, planets. I mean, Plato called the stars and the planets the visible gods. He thought of them as living beings which were conscious, including, of course, Mother Earth. I mean, all traditional societies have seen Gaia as alive. The very name Gaia, of course, is the Greek word for Mother Earth. And once when I was living in India, I was asked to give a talk on Western views of the Earth. And I said, you know, most scientists thought of the Earth as just an assembly of rocks and mechanical processes, but the leading edge of thinking saw the Earth as a living organism called Mother Earth. And my Hindu audience were deeply unimpressed because, you know, someone said, well, that's what we've always thought. You know, indeed they had. And we still call the planets by the names of gods and goddesses, Mars, Venus, Mercury, and so on. So I think in a panpsychist view, we get away from the idea that consciousness has to be limited to brains. What we do get is the idea it's associated with self-organizing systems. A table, a chair, a spoon, a sock, a computer, a bicycle are not conscious because they're not self-organizing. Machines are not conscious. They're made in factories. They don't grow like plants or animals spontaneously. They're the very worst source of analogies and metaphors for nature, really, because they're the only large functioning impressive sort of systems which are unconscious, well organized and made of many parts. So usually when panpsychism comes out, people say, well, do you mean to say my coffee cup's conscious, and ridicule it all? No one's saying coffee cups, or at least as far as I know, no one's saying coffee cups or tables, chairs, bicycles are conscious. What they're saying is that self-organizing systems, which include crystals, which exist in bicycles and coffee cups and things, may be conscious at the level of a crystal. But basically it's self-organizing systems, cells, tissues, organs, ecosystems, planets, planetary, solar systems, galaxies, and the whole cosmos, which could be conscious. And so I think that this view, which is coming about within science, starting with this very limited attempt to explain human consciousness by attributing a small amount to electrons or molecules, now opening up to the question of the consciousness of the sun, the galaxies, and the whole universe, is putting us in contact with older philosophies. The Greeks, after all, believed that the whole universe had a soul, the anima mundi, the world soul. And in the philosophy of Plotinus, the Neoplatonist, there's a lot about the world soul and how the entire universe has this soul that it's a psyche, a kind of consciousness, and the minds of everything within the universe are derived from the world soul that includes them all. They're like kind of involutions or fractal versions of the all-encompassing world soul. So I think we're returning to that view, but so far in cosmology, they go on talking about the cosmos as if it's nothing but equations and fields and matter. And now they've got multiverses, all with different equations and fields and things. But so far, this discussion that's happened with Gaia hasn't yet, at least in official cosmology, opened up to stars, planets, and the whole cosmos. But my paper, Is the Sun Conscious, was an attempt to stir up a debate about these things, because it's very hard to deny the sun is conscious given a lot of modern ideas about panpsychism.
Thank you. And thank you for your question. Sigmar, would you like to ask a question? You're still muted.
I thank you for your being, Rupert. It's really a gift. So gift is one question. As a scientist, I have experience what we're talking about other fields, from near-death experience, extrasensory perception, and so on. So I come from a place of knowing, but nevertheless, I'm very curious, and for my own teaching, I want to document what I see and other people who don't have the capacity to see. So I come from a lot of devices that, like Kirlian photography originally, then I went to infrared analysis, then with Professor Pop biophoton measurements. These are all experiments that you can do in vivo. People sit together and you can see the fields, see the interaction. But we don't have really plausible explanatory models for that. That's a difficulty. So my question to you, have you ever thought about, or what would you approach as a technical approach to document morphogenetic fields, since they include eons of time and experiences, and that means more than ever numbers can show in experiential levels? Did you ever try to technically approach that?
Yes. There are two questions. There are two parts to my hypothesis. There's the idea of morphic fields, which are organizing fields of self-organizing systems. And there's also the idea that morphic resonance gives those fields a kind of memory. Now, there are quite a number of people who have ideas of morphogenetic fields. The idea was first proposed in the 1920s, and scientists like Michael Levin, who's one of my favorite biologists, are all in favor of morphogenetic fields, but they think they work through electrical or normal known physical forces, and they don't think they have memory within them. So it's actually quite hard to do an experiment with an organism to tease apart a morphic field from other fields which are there, electrical, magnetic, and so on. However, there are ways of doing it. And one of the ways that I've found most suggestive, and I've actually tried, is working with phantom limbs. People who've had amputations have the sensation of an existing arm or leg, even though it's not there. And so the question is, can you detect the phantom field? I think of it as the field of the missing limb. The official view is all inside the brain. It's just referred to the missing limb from the brain. But I think there's an actual field there. In my experiments, I have amputees behind a barrier. Say this book is a barrier, a wall, or a door. I ask them to push their phantom arm through the barrier, and so it comes out the other side. Phantom arms go through solid objects. I have 6 areas they could push it through. We pick at random the one they pick it through, push it through. The door's closed. And on the other side, I have subtle energy medicine practitioners. I say to them, one of those 6 areas has a phantom arm sticking through it, and the others don't. Can you tell me where the phantom arm is? And so this is relying not on instruments, but on people's own fields as the detection system. And that's what a lot of subtle energy people claim to do. And the hit rates in the experiments I've done so far are very significantly above chance. Now, some people say, well, how do you know it's really the phantom limb and not just telepathy? And as well, if we've moved on the debate from where the main objection is, it's just telepathy, then that's an advance. But then to test for that, one could ask them to imagine pushing their limb through the door rather than actually pushing the phantom limb through and see whether there's a difference. That would be the telepathy control. When it comes to morphic resonance, then it's easier to test because morphic resonance means, if animals learn something in one place, they should learn the same thing quicker somewhere else. Now that's much easier and less ambiguous than testing for the fields themselves, because if that effect occurs, there's no other explanation than morphic resonance or something like morphic resonance. There have been quite a few experiments on learning. There are some new ones in the pipeline of learning in simple organisms like Caenorhabditis elegans, the popular small worm that a lot of biology is done with today. So it's easier to get unambiguous evidence for morphic resonance because if those effects occur, they're so striking and so unexplainable in any other way that I think it'd be easier to prove morphic resonance, which is what I've concentrated on, rather than the fields themselves, because it's harder to get unambiguous evidence that they're not just a result of chemical gradients or magnetic fields or electrical fields or other fields of nature. The phantom limb is the main example of teasing them apart. And I know that...
I ask you just a short moment. That is familiar for me, and I see it even with the Hansen through, because I got that gift with my near-death experience. But do you have an explanatory model for that?
Well, the explanatory model is really the model of morphogenetic fields, which is the main theme of my theoretical books on the subject. And I try and explain what the fields are, how they might work. I think they work through patterning probabilities, through biasing random events in particular directions. So I do have a model of how they work. Whether it's correct or not, I don't know, but I do have a model, yes.
Yeah. Okay.
Thank you. Thank you, Sigmar, for coming in. I think it's time to wrap up the session. Àlex, do you have any final words?
Yes, just to insist that this is an invitation and a celebration to enjoy big questions rather than big answers. So go along.
Mm-hmm.
Rupert, would you like to add something?
Oh, well, I suppose I should say that if you are interested in the following up with these big questions, do try the course. If you're specifically interested in morphic resonance, I have another course, an 8-part course online, which you can find through my website in the courses section on morphic resonance, or read the books. The best book on morphic resonance is The Presence of the Past. It's my main theoretical book. and on the big questions, the Science Delusion. And if you can think of ways of bringing these questions more into the educational system, I suppose they'd be most relevant at the undergraduate or the last year at school level. If you're a teacher, then try exposing young people to these ideas, either by showing them modules from the course or suggesting they read part of the book, or at least to start with my 18-minute TED talk, because I think they're almost certain to stimulate discussion and thinking. And I'm particularly keen on this reaching young people, because normally by the time they've graduated with a science degree, they've been so indoctrinated that they don't really question most of this stuff until they have a life crisis, a midlife crisis, or take psychedelics. And it'd be better, really, if people could be more open to these questions at a younger age, and less indoctrinated. So anything anyone can do to help that process would be very helpful.
Thank you. Thank you so much, Rupert, again. And thank you, everyone, for being here, watching, listening, and asking. See you very soon.
We've just got a couple of announcements. Michael, I'll hand it over to you.
Okay, thank you. Yes, thank you, Rupert, and thank you, Àlex, of course. So just a reminder that Rupert has created a 12-part online course with Advaya, where he argues that the sciences are being constricted by 10 assumptions that have hardened into dogmas. As he mentioned previously, this mind-transforming course is based on his award-winning best-selling book, The Science Delusion, which in the US is called Science Set Free. To register for this event, go to the Advaya website at the link in the chat, and you can also use the code 20-POTTY for a 20% discount. We also have several new series to announce for this year. On Friday, January 26th, we will begin our Book a Month Club. The first event in this series will explore the book, The Blackwing Knight, Creativity in Nature and Mind by F. David Peat, with host Alison McLeod. And this once again will be on Friday, January 26th. This year, Àlex will continue to curate and host a new series of conversations, this year entitled The Future Mind, which seeks to gain clarity and insight into important contemporary matters that require both urgent action as well as deep reflection. The first installment in this series will be on Wednesday, January 31st, with Robert Lawrence Kuhn. Thank you all so much, and we hope to see you soon at the Patty Center.